Hello guys, welcome back to my channel Algorithm Minds. My name is Asan Khurram, and in this channel I teach programming skills in MATLAB, Python and R programming. I also teach theoretical concept as well as practical programming skills in data science. So I request you to subscribe to my channel and hit that notification bell icon button. So in today's tutorial, I'm going to discuss about MATLAB programming. I'm going to teach you about the fundamentals of MATLAB programming, how you can actually define variables in MATLAB, how you can actually calculate, do matrix calculations, and so matrix indexings and so on. So it will be a fundamental and beginner friendly tutorial. So it is specially designed for those people who don't have an idea how they can actually write a code on MATLAB. So this is not just the it. I will start publishing series of videos where will I teach you about other aspects of MATLAB programming, like how you can actually define functions in MATLAB, how you can actually code loops in MATLAB, how you can actually solve an equation, and how you can actually incorporate conditional statements. So we are going to discuss it in this video by video. So let's move on and actually discuss about today's topic, which is MATLAB matrix and array operation. So this is where I will teach you how to actually you can create a matrix and do manipulation of matrix in MATLAB. So for those of you who don't know about MATLAB environment, so let me just briefly give you an introduction about MATLAB environment. So at the bottom here, you see this is a command window. So whatever you write in the script, based on a semicolon condition, it might be displayed here or not displayed here. Okay. Then we have a workspace environment. This is where your variables will be stored and shown. For example, if I define a variable, let's say a, let me go here, like a is equal to 23. So now you can see that we can see a variable a that has a value 23. So this is workspace that shows your variable names and their associated values. Now this here box here is actually represents the script. You can either make a live editor script, like just in the case I'm using live editor script, or you can actually create a traditional script, which is more like a page where you write code on it. Okay, so this is box here represents the script box, and then we have here is actually the directory box. This is where it shows the environment directly currently present on. Okay, so you can also see the address here. So it's in users, desktop, R programming, and MATLAB YouTube tutorials. So let's move on and actually discuss about our today's topic, that is matrix. How you can actually define a matrix in MATLAB. So in matrix, elements are arranged in matrix using square brackets. Okay. So the first condition you actually have to define here, in order to define a matrix, you have to use square brackets. Okay. A single row of data has spaces or commas in between the elements. For additional rows, a semicolon separates the row. So let me open up the slides here so you can actually get a better understanding of this. Okay. So the most basic MATLAB data structure is the matrix. A matrix is a two-dimensional rectangular array of data elements arranged in rows and columns. The elements can be numbers, logical values, date, time, strings, or some other MATLAB data type. Even a single number is stored as a matrix. For example, a variable containing the value 100 is stored as 1 by 1 matrix of type double. So what do we mean by that? That even a single element in MATLAB environment is stored as a matrix that has an order of 1 by 1. So we'll exercise this concept in MATLAB environment. So let's say we have a capital A variable declared, and we will associate value 100 to it. And then we are going to check the type of this A, and it says that is a double class, and it is actually a matrix of double class. So that's what we mean, that even a single element is stored as a matrix in MATLAB. So going back to the definition, how you can actually declare a matrix in MATLAB. So first of all, you have to initialize a variable name. In this case, I have initialized it with A. Then you have to put equal to sign and then assign some value to it. Then we are going to use square brackets to define a matrix in MATLAB. And in order to, if you all know that a matrix has rows and columns, now in order to define a row that has multiple elements in it, we will use spaces or either commas. Okay, so you can either use spaces or commas to define a row matrix here. So this is how you define a matrix in MATLAB. So you can see that it has values of 12, 62, 93 and -7. So let me just copy that here and paste it here and run it in command windows. Now you can see that our matrix environment has stored a variable named A that has that is actually a matrix of order 1 row and 4 columns. So in order to exercise this concept where you can either define elements by commas or spaces, let me create another matrix here. Let's say B is equal to square brackets, and I'm going to write 12, 3, 4. So it will be an order of 1, 3, 1 row and 3 column. So now you can see that we get our matrix that has an order of 1 row and 3 columns. So that's how you define a matrix in MATLAB. Then there are some predefined functions that we can use in MATLAB environment that help us to perform specific functions. Just in the case of size, which actually give us the order of matrix. How many elements are there, or what is the order of the matrix here. So I'm going to first look at the size of A, then I'm going to look at the size of B. So just write size in round brackets, so A. So this is a function, and then we pass an input argument A to it. That will actually calculates the order of matrix. Now we know that it has 1 row and 4 columns. Let's check the size of B. So now you see that it has an order of 1 row and 3 columns. So now you know how to actually define a row in matrix. But how we can actually define another column? Let's say we want to define a matrix that has 2 rows and 2 columns. For that specific purpose, we are going to use a semicolon within the square brackets. So this is how you actually define a matrix of P by Q order. Okay, so it has multiple rows and multiple columns. So I will initialize a variable named A, and then I will put equal to sign. Then for matrix definition, we will put square brackets, and within the square brackets, we will define the elements 12, 62. They can either be separated by a comma or a space. Then in order to define another row, we will use semicolon. So that's how you do it. Okay, let me just run this, and you see now we get a matrix that has an order of 2 by 2. So remember, to define a column, we will use semicolon, and if you distinguish between the elements within the row, you will use spaces or comma. Okay, now let's move on to there are some specialized functions. Just in the case I have used size is a function in predefined function in MATLAB environment. So there are some specialized functions that we can use to create matrix. Okay, and they are quite easy to remember. So the first one is actually zeros. So zeros is a function, and we put round brackets. So remember that in MATLAB function, whenever you want to give an input argument, you will have to define it within round brackets, just like here. So basically we are telling we want a matrix of zeros elements that has 2 rows and 3 columns. So this is like order P and Q, zeros, order P, Q. Okay, so this is how you define. You use specialized functions in MATLAB that will create actually a matrix that has 2 rows and 3 columns, and each element of that matrix has 0 in it. Similarly, you can change this value. Let's change this value to 4. We want 4 rows and we want 6 columns. Let me enter this, and now you see that we have 4 rows and 6 columns. In the same way as 0 is a function in MATLAB, there is another function in MATLAB that we can use to actually define a matrix that is called 1. So you have guessed from its function name once that it means it creates a matrix that has an element 1 in it. So you will just have to define the rows and columns to that function. So in that case, we are using 2 by 2, which means 2 rows and 2 columns. Let me just copy this and run in command windows. Now you see that A has an element 1, 1, 1, 1. So that's how you use specialized elements. Okay. Now, just like zeros, ones, we have also another function in MATLAB that is called diagonal, DIAG tag. And the way it works is actually takes an input argument and gives you a diagonal matrix. So for those of you who don't know about diagonal matrix, it means that the matrix that has non-zero values at diagonal is this diagonal terms and zero values other than diagonal elements. So first of all, we created a matrix A that has 1 row and 2 columns. Okay. Then we pass this matrix A to this function as an input argument. Okay, so let me revise that concept again. We first of all define a matrix that has 2 rows and 1 row and 2 columns. Then we pass this matrix as an input argument to this specialized function, which in turn will convert this matrix into diagonal matrix. So that's what we have done here. So let me just copy paste here. Now we have an A. Now we will define B, initiate a variable named B, and then we will put equal to sign and we will assign, we will use function diag of MATLAB, and then we will pass input argument A matrix. That will convert A matrix into diagonal matrix, and we store this thing in a B variable. So that's how you can do it. Okay. Let's move on and actually discuss another important concept here, concatenating matrices. Okay, this is where you actually concatenate matrix. Okay, you expand the size of a matrix by adding 2 matrices. For example, so if a matrix A has 2 columns and matrix B has 3 columns, so we will create a resultant matrix that has 5 columns, in which first 2 columns are from A and the last 3 columns are from B. So this is what a concatenating means, and we can do it by vertical and horizontal. Let me show you this, what do I mean by that. So first of all, I'm going to create 2 matrices A and B, both has 1 row and 3 columns. So let me just run this here. Okay, so now we have A and B. Now, in order to concatenate, this is quite simple to do. If you want to do horizontal concatenate, that means it will be added horizontally. Then in that case, we will use this notation here. C is equal to square bracket A, B. This can be either a space or a comma. So it's up to you, both will work. So in our case, we have C is equal to square brackets A, B. Now you see that the matrix has been concatenated horizontally. So the first 3 elements are from A, the last 3 elements are from B. So this is a horizontal concatenation by the use of square brackets. Okay, and it's the same concept we use in matrix definition, that if elements needs to be defined, they need to be defined by putting a comma or space. Now let's move on and do the vertical concatenation. It is quite easy to do. We will use the same notation, but right now we are interested in vertical concatenation. So we will use semicolon instead of space or comma. So when I run it, now you see that this is a vertical concatenation in which first row elements are from A and second row elements are from B. So that's how you can do concatenation. Now we have done concatenation. We are also teach you how to define a matrix in MATLAB. Now let's move on and actually work with some numeric sequence, how we can actually generate numeric sequence. And this topic is quite important for you to understand, because when we are going to move towards loops, where we actually apply loops, so this numeric sequence generation will actually help you to understand the loops more better. So right now it's important for you to understand this numeric sequence. So what is a numeric sequence? A numeric sequence is just like how you can actually create a sequence of series in MATLAB. So in our case, we have a notation here. A is equal to 1 colon 10. That will actually create a numeric sequence that starts from 1 and ends at 10 with an interval of 1. Let me just copy paste this here. So here A is equal to 1 colon 10. Now you can see that A is actually a matrix that has 10 values in it, and first value starts with 1 and the last value ends at 10. So it creates a numeric sequence from 1 to 10 by using this MATLAB statement here. A is equal to 1 colon 10. Now you understand this, how you can generate numeric sequence using colon notation. So in which first one is the first element. After colon we have last element. In this one, which is in our case is actually 10. Now let's move on. Now you can actually alter and play around with this sequence according to your own needs. For example, our first element in this case starts with negative 2.5 and it ends with positive 2.5. In that case, the sequence will run or generate from minus 2.5 and it will end at 2.5. So now you can see that minus 2.5, minus 1.5, minus 0.5 up to 2.5 is the thing. Okay. Now you understand how to use colon to generate numeric sequence. But now let's move on and actually add another addition to this concept, which is called the intervals. Okay. So we have like first, I say element, then we have interval. How much interval you want to give to generate the numeric sequence? You by default it is 1. As you can see that when we put 1 colon 10, it gives us 10 values from 1 to 10, and this is how you generate a numeric sequence based on your own intervals. Now you can see that in this MATLAB statement, we start with 0, we have an interval of 2, okay, and then we have a last element 10. When we run it, now you see that we have the values that have been generated are 0, 2, 4, 6, 8, 10. Now it's quite important for you to understand this concept because it will help you understand the for loops more better and easily. And the same concept applies here. You can play around with those values. You can start with 6 and you can end with 0 by putting -1 as a negative interval. So this can also be done using this statement here. Now we start with 6 and it will end at 0, first element, last element, and the interval. And it can also be a decimal point. It doesn't have to be it can also be a floating point. It doesn't have to be a decimal value. So right now you can see that I start at 1, I end at 2.1, and I put an interval of 0.2. Now you see that the interval has been changed from a decimal to a floating value. So that's how you can actually do create numeric sequence in MATLAB. Okay. Okay, before let's move on and actually discuss about array indexing first, then we will discuss about the other topics as well. Okay. So for example, we have a matrix A that has 3 rows and 3 columns in it. Okay. So you see that these are first row element, this is second row element, and these are third row element, which are separated by semicolon. Now see that we have a matrix that has an order of 3 rows and 3 columns. Now, how we can actually access a specific value out of this matrix? For example, let's say I want to access this value 8, which is at second row and second column. And it is quite easy to do in MATLAB. You just have to write a variable name, which in our case is A. Then you have to give input arguments, the row and the column, to extract a specific value. For example, in our case, I want to extract 8, which is at second row. So I will first write the row position, 2. Then I will write the column position, that is also 2. When I put enter, now you see that I get the exact value 8. So that's how you can actually access a specific value of a matrix. Let's access this value 4. So in order to access the value here from this matrix A, we are first going to drag the variable name A. Then we are going to assign the position, which in our case is second row and third column. Good. Now you know that we can assess a specific value from a variable of matrix by using this, by defining row and column value. But let's say I want to say that, okay, I'm more interested in extracting, let's say 5 and 4. Okay, now I'm interested to extract two values out of this matrix. It is quite easy to do. We will use the same notation, that is A. Then we will put round brackets, and first of all we are going to define the row. In our case, it's the row is what? Second row. Now in order to define the position of 5 and 4, we are going to use a list, okay, a matrix here. So in our case, we want to access two values out of it. So we will put, we will use matrix to define those positions. So within those matrix, I will define the column values. So the column values are such that the first column is 1 and the last column or the next column is 3. Okay. So that's by writing this, we are able to assess specific values out of that matrix element. Okay. So let me revise this concept. I want to access 5 and 4 value out of this variable A. So for this purpose, I write variable name, then I put round brackets, then I define the row number, that is second. And in order to define the positions of first and third column, I'm using matrix as an input argument. So this is the row position and this is the column position. And when I put it, I get 5 and 4. Okay, that's good. But let's say we have a matrix here. Now we are interested in extracting all the values from second row and third row. Okay, so how we are going to do that? It is quite simple to do. First of all, we will write the variable name, then we will define the numeric sequence, which is the topic we have discussed earlier. Remember that a sequence will, by using column, will start with 2, will start with the initial value and it ends at last value with an interval of 1. So in order to grab the concept, let me write this MATLAB statement here. So 2 colon 3 will be what? 2 and 3 as a matrix. And what if I write 1 colon 3 will be a matrix that's first value is 1 and the last value is 3 and with an interval of 1. Okay. So you got the concept of numeric sequence. Now let's move on. Actually initialize a variable named A and we want to assign A variable. Then as I told you that I'm interested only to get the second and third row elements. For this purpose, I'm going to start with 2 colon 3 comma 1 colon 3. So there 2 colon 3 will be 2 and 3 and 1 colon 3 will be 1, 2, 3. So when I put enter it, now you see that I have extracted the second and third row elements from it. Now the same values can be extracted by using this MATLAB statement. So in order to help you understand and grab the concept here, from 2, 3 and matrix 1, 2, 3. So we will get the same values out of it. Okay, so that's how it is. Okay. Now, one last important concept to understand in indexing is the use of AND. Okay, so by AND it means, for example, you have a matrix of 3 rows and 3 columns. So in the indexing, when we put AND, it means that we are suggesting the last row or the last element of that. Okay, so in that case we have last row and last element. Okay, so that will be, if a matrix is 3 by 3, so the last row will be 3 and the last column will be also 3. So that's how you do the indexing in MATLAB. So in order to extract some specific value and store it in a variable, let's say R, we are going to write R is equal to, then we are going to use a variable name, and I'm going to write 2 colon AND. Now keep that in mind, and will be defined as the last row in that case. And I will do the same thing from 1 colon 3. Okay. So now you see that. So the AND in array indexing refers to the last value. Okay. So in this example, it was used before comma, so it refers to the last row, and if it was used at after comma, it will be referred to as column position. For example, this thing here, like we put 2 colon 3 to define the rows, and in order to define the column, we will put 1 colon AND. It will give us the same value. Okay, now you see that the AND refers to the last value of row and column. Now you understand the concept of linear array indexing. Let's move on and actually discuss about some other topics as well. Now let's move on and actually discuss about how we can actually expand a matrix. Okay, for example, we have a matrix that has a value 2 rows and 2 columns. Okay, I mean it is an order of 2 rows and 2 columns. Then it has an elements, 4 elements in it. Okay, now let's say you want to expand that matrix. So how we can expand the matrix? We are going to use the same context of indexing. So if you want to extend the matrix, for example, by extending a means, I want to increase the order of this matrix. Currently this matrix has an order of 2 rows and 2 columns. Now I want to convert this order to 3 row and 3 column. How you can actually do that? It is quite easy to do. You will first write a variable name, then you will pass indexing in order to increase its order. So okay, we say that we want 3 row 3 column is equal to some value, and when we put enter, now what it does, that it actually assigns value to the already existed variable a. So basically we are suggesting that go to the third row and third position of matrix A and assign a value 100. So it will actually update the value of the current matrix A. So now it changes the order of this matrix from 2 by 2 to 3 by 3. So that's how you can actually define expand an order. Okay, so basically it's a concept of how you can actually update the value of a matrix. Okay, for example, let's say we have this matrix A. Now I want to actually change this value of 20. And if you, in order to do that, we are going to use the same terminology of indexing. We will first write variable name A. Then we are going to define the position. The position in our case is first row and second column. Now we want to update its value to 10. Now you see that the value has been updated. So that's the concept of actually indexing in MATLAB. Now you have seen that matrix has some row and column, but that is quite interesting to see that we also have an array or matrix that has 0. Which is called empty array. And how we can actually get that empty array, it is quite easy to do. For example, we have A is equal to 1, 2, 3, 4, which is a matrix that is first row and 4 columns in it. Now, what we will do, we will actually use a MATLAB function find. Okay, what it does, it will find some specific value based on the logic we define, within the round brackets. So in our case, I'm searching for a value that is less than 0, which is not true, and it will return empty array. So when I run it, now you see that ind, where I stored the value of this array, is actually an empty array. In order to check whether it's an empty array, we are going to use MATLAB function isEmpty. So first of all, we will define a variable named df, and then we will equate to isEmpty, and within the input argument, we are going to pass ind, which is defined here already. Now it's give us logical 1. So in MATLAB, we have logical 1 and 0. Logical 1 means true, that this array is actually an empty array. Now we are going to exercise the concept of indexing more. And for example, we have this matrix A. You see that we have this matrix A that is 3 rows and 3 columns. Now I want to delete some rows or columns in the matrix. So how we are going to do that? It's quite easy to do. Now suppose we have a matrix that has 3 rows and 3 columns in it. And now I'm interested to remove some elements or some row, or either a row or column from the matrix. For example, I'm interested now to remove this last row or third row from this matrix A. And we can do that by exercising the same concept of array indexing or matrix indexing. So keep that in mind in order to get familiar with MATLAB environment, or in order to exercise to better understand the later on exercises. It's quite crucial for you to understand array indexing in MATLAB. So that being said, so what I said that I'm going to remove this third row from this matrix A, and we are going to do that by exercising the same concept of array indexing. So first of all, I'm going to write variable name A, and within those round brackets, I'm going to define the row, which is third row, and I'm going to define the column in it. Okay, so obviously it will be all columns. So you can either write 1 colon 3, or you just write colon. It means that take all the values out of it, and then we will equate its value to empty array. So now you see that the third row has been omitted. In the same way, we can do it with the column. For example, now I'm interested to remove this third column. So we will exercise the same concept here, A. Then we will write the row values. We want to, obviously it will be all row values. So we will write colon, then comma, then we'll define the column value, which is 3. Then we will equate to empty matrix here. Now you see that values has been omitted. So that's how you can actually omit values in MATLAB. Now let's move on and actually discuss a concept about multi-dimensional arrays. So let me open the slides so you can understand the concept of multi-dimensional arrays more accurately. So this is the concept of multi-dimensional arrays. Obviously, like you have a matrix that has 2 rows and like n rows and n columns. Okay, so a multi-dimensional array in MATLAB is an array with more than 2 dimensions. Multi-dimensional arrays are an extension of 2D matrix and use additional subscripts for indexing. So an 3D array, for example, uses 3 subscripts. The first 2 are just like the matrix, but the third dimension represents a page or sheet of. So basically, you will have this like multi-dimensional array, and for example, we have a 2 by 2 multi-dimensional array. So it will be the first page will store some values, and then we will have like a sort of pages that are stored within the same variable A that will have a different value. Let me go and exercise that concept in MATLAB environment. So for example, we have a matrix A that has values this. Okay, now in order to associate another matrix value to the same variable A, we are going to use this notation here. This notation, we will use A colon comma colon, then we will define the third subscript. In our case, it will be the second page of that multi-dimensional array. So in our case, this is how it. And in order to assess the value of this multidimensional array, what we are going to do, we are simply going to use a colon, comma, colon. Then we will specifically assign whether we want to use first page, second page, third page, and so on. So now you can see I get the values of the first page. But what if I am interested to get the values of the second page? So I will use the same variable name. Within the round brackets, I will put colon, comma 2. Now you see that I'm able to get the second page values out of a same variable. So that's how you exercise the concept of multi-dimension array in MATLAB. So that's it for now. I hope this tutorial has been helpful. I will request you to subscribe to my channel and stay tuned for more videos in MATLAB programming, where I will discuss about conditional statements. I will discuss about how to define functions in MATLAB. I will discuss about integration, loops, plots, and how to solve differential equations. That's it for now. Thank you for joining me, and I will catch you soon in the next video.